Hey guys, it's Coaster. This summer I spent a stupid amount of time making it so that Link can do these dumbass dances from Fortnite. I want to show you how I did that. The most basic modding you can do with any game is to open up the ROM in a hex editor and manually change the code around to achieve a desired effect. For example, you can find the value that lists Link's tunic color and change that to something random, and boom, you get a new color. To do this, obviously you need to get a hold of a ROM, and you need it to be decompressed. The retail release is compressed with an algorithm such that the data you see isn't really what you want to be messing with. There are tools to decompress ROMs, and then there's also this leaked Master Quest debug ROM, which came pre-decompressed. Because of that, a lot of the documentation surrounding Ocarina of Time modding is about this debug ROM, so that's what I'm working with for my project. Once you get your ROM, open it up in a hex editor like HXD. From here, you can change values around that affect the game's code. But what if you want to do something more complicated than a simple color change? Like, we can't just go into the hex editor and say, swap Din's Fire for the hype dance. How the heck are we gonna do this? I'm gonna have to do some homework. Luckily, there's plenty of documentation about the game online. Most notably, we have the Cloud Modding Wiki, which is really a culmination of effort from various Ocarina of Time modders from over 10 years of poking at this game. Thankfully, there's a big section on how animations work. I'm thinking that'll give us a good starting point for this project. Digging into that, looks like there's a difference here on how Link's animations work versus how enemies and NPCs work. I know I'm just interested in Link, so let's dive into that. There are two main spots in the ROM where there's animation data: the animation header table and then the translation and rotation data. Think of the animation header table as just a simple list of all the animations, where every 8 bytes is a new animation. For example, this is the animation header for the opening the treasure chest animation. The first 2 bytes describe how many frames the animation takes to complete. This is hex value, so converting to decimal gives us 133 frames. The last 3 bytes are a pointer to the animation's translation and rotation data. And this is where the real magic happens. Translation just means where Link's entire body is located in 3D space. The rotation data describes the configuration of each of Link's limbs in the X, Y, and Z directions. The translation and rotation data combined can create every animation you see in the game. If I wanted to change the Din's Fire animation to Fortnite Dance, which is exactly what I'm doing, I'll just find the Din's Fire animation header, go to its translation rotation data, and adjust all the values so that instead of the Din's Fire animation, he's doing the dance I want. Easy, right? Psych, is not. First of all, the translation and rotation data can be thousands of bytes long, which is just not realistic to go through one at a time. Second, everything is in hex, which kind of just sucks to do math on. A lot of this data is describing the rotation of the limbs, right? But since you're in hex, instead of going from 0 to 360 degrees, you're going from 0, 0, 0, 0 to FFFF degrees. So you'd have to do some kind of conversion to even conceptualize what you're adjusting. Even if you're willing to do all of that, every time you make a change, you have to load up the ROM and see if what you did looks okay. And if something looks off in the game, it's hard to tell exactly what you need to readjust back in your hex editor. So all of this is pointing to the fact that we probably want to use some kind of program to help out editing this stuff. My first thought was to use some kind of general 3D modeling program to do this, like Blender, and being totally honest, this is probably the best long-term solution, but there's just a lot of black boxes in Blender for me. You have to somehow import this model into Blender, do the editing, and then export it back in the same form that it was in originally.
So we'll scratch Blender for now, but I wonder if it's possible that somebody's already gone down this path and already made a Ocarina of Time animation editor program.
Cloud says that there are a few Ocarina of Time animation related programs, but that only one works with Link's animations, and that is Z Satan or Satin. I don't know. I figured that looking at this program might at least give me some insight on how to best edit animations. This program was developed by X Daniel back in 2010, and the latest version I could find is from December 2010. Being such an old program, it's bound to have some issues, and at first I couldn't even get it to run. I thought it might be completely busted and just a dead end. But in an act of desperation, I found a YouTube video showing it working. Squinting at the screen in the video shows that it has a different version of the debug ROM loading, so I just went into my ROM and changed that, and it worked. Even once I got it to run, you can see it's just a viewer. Like, I can watch Link fall into this chest here, but I can't edit it. However, it still seems like a good place to start. It's able to load a ROM and parse data and display animations in real time, which are a lot of things that would take a lot of time to figure out how to program from scratch. Of course, we still can't really do much with it without the source code, but in an extremely lucky break, I found ZSatin on GitHub. So I forked the project, and then it was yet another struggle to get it to compile and run from the source code. It uses all kinds of out-of-date import packages that I either had to find the up-to-date version of or just comment out and then hope that it still worked. It also has some homemade libraries that have basically no documentation, so that was fun to figure out too. I finally got that working, and while it's definitely a bit buggy compared to the downloaded version, it will do the trick. At this point, I kind of have to do a lot of squinting at the code just to try to figure out how I want to best adjust the program to allow it to actually edit animations.
It's really hard to make coding look fun in a video, so I'll just tell you that in the end,
I made a new editor.c file that saves off the animation and then allows you to step through the frames one at a time and edit the translation and rotation values. With that working, I can jump into edit mode, be able to spin limbs around at will, and then when I'm done, I save off a text output of that animation data.
Using the program at this point, I was even able to pull off a sick dab.
But it still has some issues, namely that you have to go through the animations one frame at a time.
So I added on one more feature to really speed up the process.
Enter keyframes. This is a general concept in animation and comes standard in other programs like Blender. And keyframe means that when you adjust frames for an animation, you can mark certain frames as the keyframes. Then the program can automatically modify the frames in between the keyframes so that the animation moves smoothly from one keyframe to the next. So for something like the floss dance, you can maybe take the points where the arms are swinging all the way out to the side, mark those as keyframes, and then the program will fill in the gaps between those points as best it can. And boom, got keyframes working. Again, we're somewhat reinventing the wheel here when comparing to other tools like Blender, but I still feel there's less that can go wrong. So at this point, it's a lot easier to kind of crank out these animations. For the Din's Fire animation, which is 54 frames, we can maybe make 8 keyframes and the program will do the rest for us.
Now it's just a matter of taking that text output and pasting it back in the ROM over the original translation and rotation data.
And now we can sit back and enjoy in the game. Finally, some notes about the fairy spell animations. So, as you just saw, the path I went down was adjusting the fairy spell animations. However, I did think about adjusting some other animations.
As an extreme example, I tried randomizing all the animations in the game.
But it turns out that this can be game breaking, which might seem obvious, but I don't know. I thought the animations might just be cosmetic, but they actually control where Link can move in certain situations. For example, if you mess up the climbing animation, Link just can't climb walls. If you mess up the rolling animation, you can get stuck in like a super slide type state and soft like yourself unless you hit a loading zone. I tried to fix this by locking down some of those important animations and then just randomizing everything else.
But you can still get into weird situations where a certain animation might take a frustrating amount of time to finish.
So it really ended up being a slippery slope where you end up not even swapping out many animations at all to get the game to still be playable. And the point of all of that, really, besides just kind of being an interesting little side project, is to say that the fairy spell animations in particular are really perfect to be messing around with. You can't control Link during the animations.
You get a 360-degree view of Link to fully appreciate the animation.
And it doesn't really matter how crazy the animation gets because you're expecting to have to wait it out anyway. Obviously, that worked out pretty well to make the Din's Fire dance the hype dance. But I also thought it would be cool to have each fairy animation be a different Fortnite dance. But I ran into a roadblock here. Each spell is technically split up into 3 different animations, and some of those animations are reused between the spells. So if you edit that shared data, it's going to show up in each spell, which is kind of amusing, but if you want to do a completely different animation from start to finish, you're kind of stuck. That being said, it should be possible to find the function that gets called for each fairy spell and add in conditionals or something that will point to different animations depending on what spell you're casting, but that gets into some serious modding where you have to do like ASM, and that's out of scope for this video, aka I have no idea how to do it, but maybe we'll figure it out at some point. And that's pretty much all I have for this video. I hope you all enjoyed the quick dive into one of my projects. Let me know what you thought in the comments or if you'd like to see similar videos. Catch you later.